Problem number 1 reads, the cry for help of a man overboard is heard by a dolphin underwater. The dolphin leaps from the water and hears the same cry in air 2 seconds later. How far from the dolphin is the man? In seawater, sound travels with a speed of 1,560 meters per second. In air, at 0 degrees centigrade, sound travels at a speed of 331 meters per second. Let's first take a look at this situation. The cry for help proceeds both through the water and through the air.
Help me.
The dolphin first hears the cry for help through water, and then 2 seconds later
Help me.
hears the cry again through air. From the information given in the problem, you are to determine the distance between the original position of the dolphin when it first hears the cry for help and the man overboard that produced the cry for help. Before watching the solution to this problem, it would be a good idea to turn off your VCR and attempt to solve this problem yourself. Here is a figure in the data for our problem. If we let t be the time that it takes the sound to travel through the water from the man to the dolphin, then t plus 2 seconds would be the time that it takes the sound to travel through air. The dolphin is said to hear the sound 2 seconds later in air. The distance traveled at constant velocity can be expressed by the relationship that distance is equal to that constant velocity times the time. For the sound through water, we can write that the distance then is equal to 1,560 meters per second multiplied by the time, which we've allowed to be capital T. For the sound through air, we can write that that same distance is equal to 331 meters per second multiplied by t plus 2 seconds. And here we have two equations with two unknowns. Both d and t are unknown. What I'd like to do is to solve for the t from this equation, writing that t is equal to d divided by 1,560 meters per second, and take this expression for t and substitute it into this equation. I can then write this equation over again, writing that d is equal to 331 meters per second multiplied by t, which is now d divided by 1,560 meters per second plus 2 seconds. I can then multiply this out, and I would have that d is equal to 331 meters per second divided by 1,560 meters per second works out to 0.212 times d plus 331 meters per second times 2 seconds is 662 meters. Putting the 0.212d over on the left, I have d minus 0.212d, which then is equal to 0.788d is equal to 662 meters. I then solve that for d, and I have D is 662 meters divided by 0.788, and if you work out that calculation, that comes out to three significant figures to be 840 meters. 840 meters then is the distance from the Dolphin to the man overboard, and that is the solution to our problem. We move on now to our second problem.